this little triangle is going to be on page 5 of your I&B notebook, okay? So your whole objective today is to make sure that you can calculate no matter what they're looking for, whether they're looking for mass, density, or volume. Okay, so pick one of the squares, any one of those squares, whichever one you want, from the top. Number 3. Okay, they're giving you density, which is 0.5 grams per centimeters cubed. Okay, and that's density. Then they're giving you mass that is 20 grams. So there they have a question mark on volume. So that means they're looking for volume. So on your triangle, you're going to cover the V. You see how I'm covering the V right there? And that means your formula is going to be mass divided by that density. Okay, so this is where you put in, you're going to plug in those numbers. What is my mass? Yep, very good. And it's not just 20, because a number without a unit means nothing, okay? You're going to need those units not just for chemistry, you're going to need them for physics as well, okay? So 20 grams goes on top because that's your mass. And what's my density?
0.5.
Very good. And not just 0.5, but grams divided by centimeters cubed. Your density will always have 2 units, okay? So now mass, I have it both on top and the bottom, so that cancels out. So the only thing that's left is my centimeters cubed. That's going to be my volume. So you're going to take 20 divided by 0.5, and how much will that give you? I'm sorry, I didn't hear that. 20 divided by 0.5. Yep, 40, very good. And so 40 centimeters cubed is your volume. Good job. Okay, that's it. Where do we have a question so far? Are we sure? No questions? Okay, real quickly, just a reminder that mass can be grams, kilograms, pounds, any of those is mass, okay? Volume can be milliliters, liters, centimeters cubed. Any of these are volume. Density has to have 2 units, so you can have grams per liter or kilograms per milliliter or anything like that, okay? All right, and do another one. So let's do number 7. Okay, let's do number 7. And we still have your same little shortcut. Okay, what's my first given for number 7? For number 7, what's my first given?
Volume of 15 milliliters.
Very good. And so my volume is 15 milliliters. Okay. What's my second given?
Density 40.5.
It is 40.5, but it's mass. Very good. Because it's grams, the 40.5 grams is mass. So because they're giving me mass and they're giving me volume, what am I looking for? Density. Very good. So because I'm looking for density, my formula is going to be mass over volume. Okay, so what number goes on top? Yep, the 40.5. I heard it back there somewhere. Very good. Okay, don't forget your unit. And what goes on the bottom? Yep, the 15 milliliters. Okay. And so because you're looking for density, it's going to have 2 units. Your units are going to be grams per milliliter. Now you're going to take your calculator and you're going to put 40.5 divided by 15. How much is that going to give you?
2.7.
Very good. Yes, 2.7. Good job. Okay. Did everyone see how we set that up? Or do we have a question so far? You sure? Be positive. Okay. All right. Let's do something a little different. Let's do number 10. Let's do number 10. Okay, what's given? What's the first thing that's given? Yep, you have your mass, and it's 1896 grams. Now, are they giving you volume? Nope, but they are giving you a way to figure it out. So you're working with a block, and one side is 8.4 centimeters. And you have to times that times your 5.5 centimeters. And they're giving you another centimeters of 4.6 centimeters. Oops. Okay, now remember that volume is centimeters cubed. Okay, so centimeters times centimeters times centimeters will give you that volume. So you'll have to do 8.4 times 5.5 times 4.6, and that will give you your total volume of 212.52. Now, do I have volume? Yes. Okay. So now you can look for density. Okay. So 1896 grams divided by the 212.52 centimeters cubed. This will give you your density in grams per centimeters cubed. Okay, so what do you have to put in the calculator first?
1896.
Very good. Yes, the 1896, and you're going to divide that by the 212.52, and this will give you 8.9. You can leave that as 8.9 or 8.92. Either one will be your density. Okay. Now, a little warning, whenever you have problems like this, you must show your work. Okay, because you get points for the work, you get points for the units, and then you get points for the answer. Okay, so no work, no credit. All right? That's going to happen in physics as well. So we start in chemistry, and then it leads like that into physics. Okay, what questions do we have? Are we doing okay? Does it seem easy enough? One more? Yes? Okay, so let's do one more. Let's do something kind of similar to lab. We might have lab tomorrow as long as I can get those scales. Let's do number 14. Number 14, they're giving you 28.5 grams of iron, and this is your mass. Okay. And then they're giving you a graduated cylinder, and this graduated cylinder has a water that fills up to 45.50 milliliters. Okay? Okay, then they put a piece of iron inside. So anytime you want to find the volume of a solid, you're going to put it into water. It's going to lift up the water up to 49.10. Very good. Okay, this is called displacement. Okay, and we're going to be doing this in lab. Okay, and so the amount it moved from its original spot to the second spot, that's your actual volume. So 49.10 minus that 45.5, that's your true volume. 9.10 minus your 45.5. So what's my volume here? 3.6. So it's going to be 3.6 milliliters. Okay, and this is what you're going to use to find that density. So that density is 28.5 grams. You're going to divide by the 3.6 milliliters. Okay, so now 28.5 divided by 3.6. What's my density? Very good. And that's it. Okay. And this is called displacement. This is something that hopefully we're going to be doing in lab tomorrow. You're going to have pieces of iron or zinc or nickel or something like that. Copper. Okay, and you're going to be using a cylinder to figure out your volume. Okay, now, but before you do that, you have to get your mass. So you have to use the scale. Should you figure out the mass first and then do the volume? Yes, very good. Because remember, you have to put it in water. Once you take it out of water, what's going to happen if you weigh it after that? Are you going to have extra mass? Yes, because some of the water droplets that are on the actual solid piece are going to be there. If you put it on the scale, you're going to be weighing not only the mass of that object, but also the water droplets that are on it. Okay, so you don't want to add mass, you want the true mass, okay? Okay, where are we? How are we doing? We doing okay? Do we have any questions? No questions? Are we sure? Okay, go ahead and get started. You're going to do both sides. Remember, you must show your work and you must include your units. Once you're finished, make sure that your name is on it and the period. You're going to turn it in up here and we'll grade it.